In this video, we're going to have a look at what function notation is. Now, I want to pretend for a moment that I've got a machine. So I'm not going to draw a fancy machine here, but this is my machine. And this machine has an input, so an input just over here, and an output just over here. And whatever's put into this machine, it'll do the exact same thing every time and then submit an output response. And you can think of computers very much like that. You put an input into your computer, it performs a specific function and then spits an output or spits out a response. Now let's say that this machine is built to square the input, and then after it's squared it, it's going to double it. Then it'll subtract 3. What I've now done is I've programmed this machine to perform a specific function for whatever that we input into the machine. And let's say that I input a value of x into this machine. Well, my output will first have this x squared, so my input squared. It will then double it, so it'll multiply it by 2, and then it'll subtract 3. So what you can now see is, for whatever I input to this machine, it'll output a response. And we write this sort of function machine like this. We represent it like the f of my input of x in this particular case, which it outputted 2x squared take 3. Now I don't have to just input the value of x. I could input a number, or I could input any other variable that I'd like. And the machine itself will perform the exact same operation. It will square the input, it will then double it, and then it'll subtract 3. So what's important is when you see this f of x as it's pronounced, it's a function machine, and that machine has got the current input of x. But we can now represent this as different sort of functions. For example, what if I was to look at the function of 5? What if I was to input that function of 5? What's really important here is to connect this. If we've got our function represented in this format here, what we're actually doing is using substitution, a skill that we've used to absolute death to this point, where we're going to substitute our value of x with the value of 5. And it still works as if you thought about it as the function machine. First we're going to square it, then we're going to double it, then we'll subtract 3. So when we represent this, it'll be 2 multiplied by my input of x, but my x is now 5. So 2 times 5 squared, and then subtract 3. So when I square my input, that'll be 25. So it'll be 2 times 25, subtract 3. Now I double it, so that'll be 50, subtract 3. And then I subtract 3 from it. So therefore, my function of 5 with this particular function machine will end up equaling 47, or submitting me an output of 47. Let's try another input. Let's try the f of -4. So inputting -4 into my function machine. Well, just thinking about this, I can just substitute -4 here where I've got my x. So this will be 2 multiplied by my -4 all squared, subtract my 3. Now we'll have to square it first, which is what my function machine actually wants. So -4 times -4 will be positive 16, subtract 3. Then we've got to multiply this, so then we've got to double it. So that'll be 32, subtract 3. And then finally we've got to subtract 3 from it. So therefore my function output, when I input -4, will end up being 29. Now this works not only for a number or a single variable, but we can actually input another function into this. So for example, what if I wanted to know what my output would be if I put an input of x plus 1? So I'm inputting a function now. Well, the same thing will occur. I'll need to square the input, then I'll need to double it, and then I'll need to subtract 3. Now I can do this or achieve this by substituting my x with x plus 1. So let's do that. This will be 2 multiplied by x plus 1, but I'll need to square that first, because I'll need to square my input first. I'll multiply it by 2, then I need to subtract 3 at the end. So now I've got to expand these brackets first, and I've got a perfect square here. So this will be my first term squared, which is x squared, my two terms multiplied with each other, which is just 1x, and then double it, so 2x. Then my last term squared, which is 1 times 1, or positive 1. And I still have that subtract 3 at the end. So now I've squared my input. Now I've got to double it. So I've got to multiply this 2 out. So this will be 2x squared plus 4x plus 2. That's 2 multiplied by everything. Then I need to subtract 3 to my function at the end. From here, I'm actually using my collecting like terms skill. So these two are my like terms. So therefore, my function, when my input, my function output, when my input's x plus 1, will be equal to 2x squared plus 4x and subtract 1 at the end. So what function notation is it's a little bit like a machine. It can be thought of that. It's going to perform the same function every single time to whatever input that it's given. And it's going to output based on its input. And we can represent it like this. And we pronounce this as the f of whatever's in the bracket, the function of my input. So in this case, it's my function of my x. Now my function of my x is represented here. If you've got this and you want to look at the function of something else, so the function of 5, the function of negative 4, we can use substitution. So we can start using some of the algebraic skills that we've got already. And that's the key thing to identify here. This is my input. I'm substituting that into my function.